Hello and welcome to CEB. Before starting the video, if you're not subscribed CEB, do subscribe it, like the videos, share the videos. So today we will discuss safety algorithm for single instance of resource with multiple safe sequence. So here what we are going to do, first of all, we are going to find out the total number of resources. That is our first step. So the first step is step number 1. So the total resources in our system. For example, the resource is printer in our case. So what we are going to do, we are going to calculate the total number of resources. So the formula will be the sum of all allocated resources plus the available resources. Okay. So what is the sum? 3 plus 5 plus 7, that is 15, plus available resources is 3. So the sum is 18. That is, we are having 18 printers in our system. Now after that, the second step is to find the need matrix. So the step second is calculation of need matrix. Okay, so how we are going to find out what is the formula? The formula for need matrix is max minus allocated. Okay, so what is the total number of resources that was allocated to process P0 is 3, and how much that was needed previously is 4. So the 4 minus 3 will be the need will be 1 for your process P0. For process P1, max is 8, allocated is 5. The total number of resources will be needed by process P1 will be 3. By the process P2, it will be 12 minus 7. The answer will be 5. So that is your total. We had calculated the need matrix for processes P0 to P2. Now the next step is we have to follow the step. We have to check whether the need of any matrix, the need of any process is satisfied by the available resources or not. So we'll start with process P0. So what is the need required by process P0? Process P0 required one printer. And how many printer we are having in our hand? So where is that available? Where is your work? Your work is nothing but the available resources in your system. So this is available is 3. So process P0 requesting for one printer, and in our hand we are having 3 printer. Whether this condition is satisfied, this condition is satisfied. So what we are going to do, we are going to make the 6 sequence. We have started with P0. After this thing, now we are having 3 printers in our hand. Whether the need can be satisfied by process P1 also, because P1 is also requesting for 3 printer. So here the need by process P1 is also satisfying the condition. Process P1 requesting for 3 printer, and in our hand we are also having 3 printer. So this condition is also satisfied. So again we can have a second safe sequence starting with P1. It is meaning that it is not necessary to always start with P0. We can select any process. Okay. So here we started with P0. That is also okay. Here we can start with P1. Now we will check for P2. Whether the need of P2, which is 5, is less than or equal to 3. No, that is not true. So we can proceed with P0 and P1 only. So let us make partition here so that we are going to calculate 2 different process safe sequences. Okay, now with the process P0, how many processes, how many printers will be released by process P0 if the need is satisfied? So here instead of writing work complete word, I am using W. So W, your new work will be current work plus the resources that was allocated to process P0. So what is your current work is how many printers are available is 3, and how many were allocated to P0. As P0 has completed its task, is going to release it. So process P0 was allocated with the resources 3. So that 3 printer will be released by process P0. So how many printers are available now in our system? So that is 6. And now if you are following process P1, so the new work will be what? Current work plus the resources that were allocated to process P1. So the current work was 3, and how many printers will be released by process P1 is 5. Okay. So 5, and then the total number of printer that will be available after this, after P1 is going to terminate will be 8. Now with P0 we will follow and we are going to check how many printers we are having. We are having now with now we are having 6. With 6 printer in our hand, now P0 is terminated in this case. So who's remaining? P1 and P3. With the 6 printer, can I satisfy the need required by the process P1 or the need requires by the request by the P2? So both the conditions are satisfied. That means with P0, I can jump to P1 also, and I can go for P2 also, because it is not necessary to go in sequence. After P0 where to go for P1, after P0 I can go for P2 also, so we cannot maintain the sequence. So here again we are going to partition it. So after P0, after P0 is completed, we are having 6 printers in our hand. So the need of process P1 is now satisfying the condition. So what is the need of process P1 here is 3. Okay, and 3 is less than equal to 6. Now what will the next step is? Your new work will be current work plus the resources allocated to process P1. So the current work is 6 and the resources that were allocated to process P1 was 5. Okay, so what is the total? The total number of resources is 11 and P1 is added in the sequence. Now we will go for the next alternate. The next alternate is we will check for the need of process P2, whether it is less than equal to work. What is the current work is 6. What was the need made by the process P2 is 5 resources. Whether the 5 is less than equal to 6, this condition is satisfied. That means now the current work, now the new work will be the current work plus the resources allocated to process P2. So the current work is 6 and the printer that was allocated to process P2 were 7. So what will be the total? The total will be 13. Okay. Now we will go for this one. After P1 here, that is this sequence, P1 who will be selected. Now we are having 8 printer in our hand, and if you are going by this method that we are selected P1 first. So with the 8 printer in our hand, we can satisfy the request made by P0 and request made by P2. So the next step will be with the P0 or P1 with the next step, with the next process selected as the P2. So if P0 is selected, what will be the case? We have to first write down the condition. We are checking whether the need of P0 is satisfied by the work. What is the need of P0? I think it is 1. Let me check it. Yes, it is 1. And it is less than equal to work. So this condition is satisfied. So now what the P0 will do, it will release its resources. So the new work will be the current work plus the printer allocated to process P0. So the current work is A. The printer that was allocated to process P0 at that time is 3. Okay, so 3 will be added. So 8 plus 3 is 11. Now we will go and check for this sequence. So the need of process P2 is less than equal to work. How many resources are needed by the process P2 is 5. Now whether the 5 is less than equal to 8, now this condition is satisfied. So the current work, the new work will be the current work plus allocated to process P2. So the current work is 8 plus allocated to process P2. How many resources were allocated? Were 7. Okay. So that will be 15. Now we will go and jump for this one, for this sequence. Now P0 is over, P1 is over. Now who is remaining in our system? So we write down who is remaining is definitely P2 is remaining. So that is going to complete our sequence. But before writing it, we are going to cross check whether the need of process P2 is satisfied by the currently available printers. currently we are having 11 in this case. In this case, we are having 11 printer available. So now we will check whether the need made by the process P2 is satisfied or not. Process P2 requires 5 printers. So the 5 is less than equal to available. So that condition is satisfied. And the new work will be the current work plus the allocated printer that were allocated to the process P2 will be 11 plus how many printers were allocated to process P2. Process P2 was given 7 printer. So 11 plus 7 is 18. That is, this condition is this number. If we are having at the end, we are having 18 printer and already we are calculated in the beginning. So we were having 18 printer and at the end we are getting the 18 as the output for total number of printer in our system. So this solution is correct. Now we will go for the next step sequence in which we have started with P0, P2, and now we are checking for the next process. The next process will be definitely P1, but before writing it, we have to find out whether the condition is satisfied or not. Need of your process P1 is less than equal to a work or not. How many printers were needed by the process P1? Process P1 requires 3 printers. So whether the 3 is less than equal to 13, this condition is satisfied. So now next step is new work. New work is equal to current work plus, so new work is equal to current work plus allocated of to process P1. So how many printers we are having in our 13 and how many were allocated to process P1 initially? That is 5. So 13 plus 5, what value we are getting? Again, we are getting same value, which is 18. So that is what needed, which we had already cross-checked in the beginning, that total number of printer in our system is 18, and at the end, after the termination of all the processes, we are getting 18 printers back to your system. So this sequence is also correct. So this is also a valid safe sequence for your question. Now we will go for the remaining safe sequences. Okay. So what is remaining? Only after this one, P1, P0 is completed. Now we will go for definitely for the last one, which is P1, P0 is completed, which is remaining now, P2 is remaining. So we will check whether the need of P2 is less than equal to work. Yes. So what is the need of process P2? Process P2 requires 5 printer, and how many printer we are having? We are having 11 printer. So 5 is less than equal to 11. That condition is satisfied. So the new work will be current work plus allocated to process 2. Okay, so the current work is 11, and how many printers were allocated to process P2 were 7. Again, 11 plus 7 is how much? 11 plus 7 is 18. That is, your answer is correct, having the same sequence P1, P0 and P2. Now the last one, which is remaining one is P1, P2. So P1, P2, so if P1 and P2 has completed that task, so who is remaining in the system? Only process P0. So now check the condition whether need of 0 is less than equal to work. How many printers are needed by the process P0? Only 1. How many printers we are having in our hand? 15. So this condition is satisfied. So the current work, the new work will be the current work plus allocated to process P0. So the current work was 15, and how many printers were allocated in the beginning to process P0 is 3. So you tell me the answer. 15 plus 3 is again 18. That means again we are getting the safe sequence, which is the correct solution for your answer. So for this kind of question, I'm getting 4 safe sequences. So which is again, and how, whether they are correct or not, they are correct because in the end in the system I am having 18 printers. So if you like the video, do share, subscribe the channel and comment if you are having any kind of query or doubt. Thank you for watching the video.